For centuries, humans have looked toward the stars to find mystery and wonder. Yet, beneath our very feet lies a world just as alien, the deep sea. It is a place where sunlight fades into darkness, pressure rises beyond imagination, and life takes on forms that seem to belong to another planet. Exploring the deep ocean has always been one of science's most difficult and fascinating challenges. The story of deep-sea discoveries is not only about technology and exploration. It is about humanity's endless curiosity and courage to go where no one has gone before. The ocean covers more than 70% of Earth's surface, but we have explored less than 10% of it in detail. The deep sea, which begins at around 200 meters below the surface, remains one of the most mysterious parts of our planet. At those depths, sunlight disappears and temperatures drop close to freezing. The weight of the water above is so great that even the strongest human bodies and machines would be crushed without special protection. Despite these dangers, explorers continue to push the limits. Early ocean exploration relied on simple tools, ropes, nets, and primitive diving bells. These gave scientists only brief glimpses of what lay below. But in the 20th century, technology changed everything. Submarines and remotely operated vehicles, known as ROVs, began to travel thousands of meters beneath the surface. Sonar systems painted pictures of underwater landscapes, revealing vast mountains, deep trenches, and hidden volcanoes. Each discovery reminded humanity that the ocean was far more complex than anyone imagined. The most dramatic moment came in 1960, when Jacques Picard and Don Walsh descended into the Mariana Trench, the deepest part of the ocean. Inside a small submarine called the Trieste, they reached a depth of nearly 11 kilometers. What they saw shocked them. Life thriving in darkness where no one believed it could exist. The more scientists explore the deep sea, the more they realize how interconnected it is with life on the surface. Every discovery reveals new ecosystems, new species, and new understandings of how our planet works. For example, hydrothermal vent communities show how organisms can live in extreme heat and pressure. Giant tube worms, deep-sea crabs, and bacteria thrive in toxic environments that would kill most surface life. Studying them has helped scientists understand how life adapts and even inspired ideas for biotechnology and medicine. The discovery of deep-sea coral reefs was another revelation. Unlike shallow corals that depend on sunlight, these corals live in complete darkness, feeding on nutrients drifting from above. They form vast underwater forests, home to fish, crustaceans, and other marine creatures. These ecosystems are thousands of years old, yet they remain fragile. As deep-sea mining and trawling increase, these corals are at risk of being destroyed before they are fully understood. One of the most exciting areas of deep-sea research is bioluminescence, the natural ability of organisms to produce light. In the dark depths, light is communication. Creatures use it to hunt, attract mates, or confuse predators. Some fish flash patterns like Morse code, while others glow steadily, creating floating galaxies in the water. Scientists study bioluminescence to develop new medical imaging techniques and technologies inspired by nature's light. As technology advances, humanity is entering a new age of ocean exploration. Satellites, underwater drones, and quantum sensors now work together to reveal what was once invisible. Future explorers dream of sending fleets of intelligent robots to map every corner of the ocean floor, from polar ice caps to volcanic trenches. Each discovery will bring new opportunities in science, medicine, and sustainable energy, but also new ethical questions about how to balance progress with preservation. Deep-sea mining, for instance, has become one of the most controversial issues of our time. The ocean floor is rich in minerals like cobalt, nickel, and manganese, essential for making batteries and renewable energy technologies. Companies see economic opportunity, while scientists see ecological danger. Mining machines could destroy habitats before we even know what lives there. The debate is not just about profit, but about responsibility to future generations. Meanwhile, new research shows that deep-sea microbes may hold the key to curing diseases or creating sustainable materials. These organisms survive under extreme conditions, developing unique chemical compounds that could inspire new medicines, biofuels, and even materials stronger than steel. The possibilities are endless, but they require respect for nature's balance. The ocean also plays a crucial role in fighting climate change. It absorbs about a quarter of the carbon dioxide humans release and produces more than half of the oxygen we breathe. Protecting the deep sea means protecting the planet itself. Initiatives like marine sanctuaries and global agreements aim to preserve at least 30% of the oceans by 2030. This vision reflects a growing awareness that the deep sea is not a distant world, but part of our shared home.